Welcome to this Java Break with Basis. Today's topic is all about data, basis data and third-party data, how we can provide access to our basis data and how we can consume third-party data from our business applications. Let's look at our agenda. Firstly, we'll look at the basis data access tools and techniques. We'll look at accessing third-party data from BBJ or from your Pro5 or Visual Pro5 application using JDBC and ODBC access. We'll talk about some of the benefits that you'll get from opening up access to your data and utilizing the basis toolsets. And then we'll answer your questions. Let's firstly look at the overall view of our session today. We're going to be looking at, say, our production systems down here. So we have BBX applications, be they BBJ, Visual Pro5, or Pro5. They'll probably be accessing your basis data files using read record or write record type statements. And here we'd have our database server. So this would contain the data dictionary and the SQL engine to allow access to third-party applications, Microsoft Excel, OpenOffice, Crystal Reports, iReport, report writing tool. And of course we also have the situation where our BBX applications can access our basis data through JDBC and ODBC from BBJ, or from Visual Pro5 using ODBC we could access third-party data, Oracle, MySQL, Microsoft SQL Server, etc. But we can also access all of that from JDBC by utilizing BBJ's XCall functionality from within Visual Pro5 or Pro5. So we have a plethora of access opportunities, and we'll also talk about some of the performance ramifications during today's session. So let's talk firstly about database and data file replication. We'll talk about what it is, because this really sets us up to create a read-only copy of our data for data access to a third-party tool or to basis report writing tools. So we can replicate specific files or directories from one machine to another, on the same machine, from different machines on a network, and to cloud machines. We can replicate entire databases as well. And this is all completely transparent to the users of the production system. And any changes to the files are replicated, and only the changes to the files are replicated, making it extremely efficient and very low overhead on the production system. So as an example, we could have our primary data sitting here in the BBJ primary source and have Pro5, Visual Pro5 or BBJ as the application server accessing that data. And then we can have a replicated copy of that data, either files or the data dictionary and database itself, on the same machine. Or we could go and replicate that data across the local area network. And finally, we can replicate it across the wide area network, even to a cloud machine. So what are the benefits? One of the primary benefits is disaster recovery. We can create a live database backup as well, offsite, local or multiple, as I showed earlier. And you never have to bring the server down to impact the users to do your backup. You can just pause the replication job and do a backup from the remote site. And that gives you the opportunity to do a stateful backup with the users still on the system. So you can briefly pause the user's usage of the production system and then do a backup on your remote server while allowing your users to continue with their production operations. One of the strongest and one of the most powerful aspects about database and data file replication is the ability to have a read-only database copy for data mining, for warehousing, and for reporting. That offloads the queries and reports, that conserves your resources in your production system, so there's no overload or additional effort being placed on the production server. And it also can give you a database in closer proximity to the user group. To see more, I would encourage you to go and review one of our previous Java breaks on database and file replication. But just to summarize, they are very simple steps. We copy the data to the target, and the changes to the source are also made to the target in a read-only fashion, and that remains in sync throughout. No changes are required to your application code. And here's a little example of the environment that we at Basis run. So we have our data here on the West Coast in California, running in the Amazon Web Services cloud, and we have a replicated copy running on the East Coast, and we also replicate that data across to Japan and to Ireland. All of that happening to production data real time while the system is in use by our customers throughout the world. But enough from me. Let's have a look at a demonstration of database and file replication. Let me hand over to Jeff Ash to take you through that.
Let's look at how easy it is to create a database replication job. We pull up our replication wizard, select database replication because we want to replicate the entire database. We select the database we want to replicate. It populates the information for us. We need to give it a job name. We specify where we want it replicated. In this case, we're going to replicate it to our local machine, but you could put in a remote BBJ services installation so that it could replicate elsewhere. Put in a user and password that we want the job to use when talking to the replication server. We can select SSL if our remote machine is using SSL for the file system. It automatically selects our data dictionary and data directories for us. We can also exclude any files that we don't want in our replication job. All that's left now is to test our connection, make sure our settings were put in properly. Our test was successful, and so we're ready to hit next and create our job. It's that simple, and now we have replicated an entire database to another location. Once that is running, we also have a read-only database that we can go and run queries on, and that's created for us automatically. So we can perform queries on this data. Now let's take a look here at what happens when we change our data in our source database. Note that we're going to be changing our source database. We're going to insert a new record into the category table. When we perform that operation, it's successful. Now let's go over to our replicated database. When we click over here and we query that table, notice our new record is immediately available in there. Note that the location is our, in fact, replicated database directory, which is different from our original source database and directory. So in just a few simple clicks, we have done a couple of different things. One, we have created a live backup of our entire database that can be easily recovered in the event of a disaster. And two, we've created a data warehouse where we can offload our long-running reports and our heavy processing intensive queries.
Thanks, Jeff. Well, now that we've got a good copy of our data available for access by third-party tools and report writing type tools, let's talk a little bit more about how we can go about that. Firstly, database mining data warehouse is our most commonly used need, or commonly sought after need by management to be able to gain access to that production data that's in the legacy Business Basic system. Firstly, the tool that's going to be used by any of these third-party tools to access basis data is going to be SQL. That's the most commonly used tool, structured query language. And you may be asking yourself, how do I get my data that's been defined with read record, write record type syntax, how do I make it available via SQL? Well, good news is it's pretty simple. As long as you have a data dictionary, a basis data dictionary, you're set. We have an SQL engine, we have JDBC and ODBC drivers, and you can open up access to your data. But probably one of the biggest obstacles to taking advantage of the data dictionary and the SQL engine has been access permission. We don't want these casual users to be able to write to our database and corrupt it, make changes inadvertently via SQL. It's a very powerful tool after all. And so we've added some new functionality that gives much more granular control to access to the database. That's object level permissions, access control via SQL. And then finally, we'll also talk about several areas of enhancements to our SQL performance. How we can make it a lot faster by doing table analysis, and we'll look at some practical examples and demonstrations thereof, and query analysis, using the JDBC prefetch algorithm, and then finally connection pooling, where we preserve the existing connection and reuse it, thereby speeding up access to the database. So firstly, that question of no data dictionary, well, no problem really. In our basis tool set, if you go into the database management, you'll see this example where we've utilized the string template. So here you can put in your string template or take your IO list and convert it into a string template. Really trivial task, and that'll generate your columns. So generate it automatically for you. And then next step would be to generate from your data file, generate the various indexes that exist on the table. The next point may be, well, maybe your data is not well normalized. So if it's not normalized, you can use views. In other words, get a view of the data by doing a selection on a particular record type, for example, and offer that up as a virtual view of your non-normalized data. And new in BBJ 12, we're introducing complex views, very extended capabilities to create complex views. You can nest SQL statements. Nesting SQL statements is new to BBJ 11, and that'll be incorporated into the complex views. You can also use stored procedures. And that means you can have BBX code with read record to access your data in the way that it was originally designed. And then you can populate an in-memory record set and then offer that up to SQL as a virtual table. So lots of ways to get to that data, even if it wasn't originally designed for structured query language relational database management system type access. And of course, your store procedure can be a component of a view or a nested SQL statement. So let's talk about managing object level permissions, perhaps the missing piece in the puzzle to open up access to your data to third-party SQL-aware tools. So we've given you access permissions at table, view, and store procedure level. You can manage these at a granular level. No modifications are required to your application or to your current security infrastructure. This allows you to manage that data access from the third-party applications via ODBC and JDBC. You can assign user and group permissions to individual tables, views, and store procedures. And you can assign different select, update, delete, and insert permissions per user or per role or group. So we introduced the concept of roles to your security permissions. Store procedures can also be controlled. We can allow some users or certain roles to execute certain store procedures and prevent others from executing those store procedures. Finally, just a quick comparison of the legacy capabilities we previously provided, where you could have users have read or read write just across the whole database. Permissions were the same for every table, view, and store procedure. And permissions could only be set from the Enterprise Manager or the Admin API. And there was no way to group users with similar permissions. Now, the new object level granular capabilities, you can give users specific select, update, insert, delete, or combination thereof access to the data. Users can have different permissions on each table, view, or store procedure. And those permissions can be set using standard SQL grant revoke statements. And finally, it supports grouping users with roles. So let's have a look at an example of that. Back to you, Jeff.
One of the great powerful new features in the BBJ database management system is the ability to manage what we call object level permissions. Previously, you were only able to manage permissions at the database level. Now you can manage it all the way down to the table, view, or stored procedure level. To do that, you simply come over to a table, select the permissions, and then what I've done here is I've added the human resource and management groups to our list of permissions for this table. Now, our human resource group consists of people in the human resource department who, let's say, need to be able to delete, insert, select, and update this table. However, our management group, those in the management department, they only need to select from this. We don't want them modifying the data, but we do want them to be able to see it. Anybody else, other users who are not in those two groups, we don't want them to access this table. And so we won't add any permissions for those other users. Once we've done this, now any access from outside applications or from SQL operations within BBJ itself will abide by those permissions. So I'm logged in here as user JAsh, who is not part of the human resource or management departments. And so when I execute this query, note I am denied access to that table because I do not have select privileges on the sales rep table. So this powerful new feature gives you the ability to manage those permissions at a much finer level. Now, the real beauty of this is that you can use this new feature today without any modification to your existing applications or the application security infrastructure. This will work in conjunction with whatever your application has set up to manage user permissions. It gives you the ability to add an additional layer that manages access to your data from third-party ODBC or JDBC applications.
Thanks, Jeff. Let's move on and talk about SQL Engine performance enhancements. We're going to look at several areas: table analysis, optimization, query analysis, JDBC prefetch, and connection pooling. Firstly, table analysis. We want to give you the ability to optimize your queries, and we'll show you how it gathers statistical data during execution of the analysis, and the optimizer therefore can choose the best key or index to use when the query is run. So we'll look at a couple of examples of that. Let me hand over to Jeff to run you through that.
Table analysis is a very powerful feature that's built right into the BBJ SQL engine. What it does is it helps the SQL optimization engine determine the best possible way that a query can be optimized. Basically what it does is it gathers statistical data that is used by the optimizer during the execution of SQL select or update statements. This statistical data allows the optimizer to intelligently choose the best key or index to use for iteration over the records as it locates the records that match the criteria specified in the where clause. The best way to understand how table analysis works and how it actually benefits you as the user is to look at a very, very simple example. Our example uses a single table in our database called customer. Basically, this customer table is made up of customer ID, first name, last name, city, state, zip code, and phone. It has some indexes on some of the columns in this table. It has one on customer ID, that's the primary key. It has one on last name, and it has one on state. Now, some basic statistics about this table: it has 100,000 records in the table. The last name column has 1,000 distinct last names in this table. The state column, all of the records in this entire table contain the state, New Mexico. So here's our example. We're going to run a select statement that says select star from customer, where the last name equals Abbott and the state is New Mexico. Very simple query. Here's the question: which index should the optimizer use? Well, without table analysis, what it does is it will use the first one in the list of indexes or keys that it finds usable for this where clause. But with table analysis, it uses the actual best one. So let's take a look at our example in action. Note here in the BBJ Enterprise Manager that our customer table has 100,000 rows. It has no table analysis information available. That's indicated in this column here. Now let's execute our statement and see how long this takes to return. That took 3,801 milliseconds, or 3.8 seconds. That doesn't seem like a long time, but we can certainly get better performance out of this. And let's say this table had 1 million records in it. Well, then we could expect that to take 38 seconds. You're starting to see the importance of why table analysis, why the best optimization possible is something very desirable for us. I just completed running table analysis on this table. We can see when that was run and completed in this column here. Now let's execute our statement again. Wow, that was much quicker, only 171 milliseconds, not even an entire second. So what did this do for us? Well, table analysis gathered information about the uniqueness of values in each of the indexes. And then using that information, the optimizer was able to determine that on average, the best index to use was the one on the last name column. Why is this? Well, because using the index on state will still force us to look at every record in the table, while the index on last name, on average, will only require looking at 100 records to return the same exact results. Remember, from our statistical information, there are 100,000 records in this table. There were 1,000 distinct last names, meaning that each last name would have on average 100 appearances in the table, while the state column has the same value for every record.
As you might imagine, table analysis could take a significant amount of time across a large data set with a lot of data and a lot of keys. So we suggest you offload that analysis work, copy the database to another machine, mount it in the Enterprise Manager, perform the analysis on the second machine, and then you can copy back the frequency.dd file to the live systems data dictionary directory. Our next tool that we suggest you utilize is our query analysis tool. It's an Enterprise Manager tool, runs in the background, and analyzes every query run in the database to reveal which parts of the dataset may need indices added to it. It gives you the details of the table, the score, and if it's already indexed. You You can also quickly create an index with just a right click on the query. So let me hand back to Jeff to take us through that.
As a database administrator, one of the things that you'd like to do for your users is provide them the best possible performance with their applications as well as the reports that they run. The BBJ Enterprise Manager provides you with a powerful tool to assist you with this task, and that is query analysis. Query analysis runs all the time in the background, analyzing every query that's run in a database. This information is then made available here on the Query Analysis tab, and what you can do is take a look here and see what parts of your database may need indexes added to provide better optimization for queries run on your database. Now what you see in this tab here is a list of items, and each item has the table, a list of columns, a score, and whether that list of columns is indexed or not on that table. What you can do is take a look at this information here and determine if queries are using columns that are indexed. So let's take a quick look here. Under our column list, we see that a number of queries are done using the last name, and we see that there is an index on the last name column. So we're okay. Now the higher the score, the more often queries use that combination in the where clause. We also use state fairly often. That also is indexed. But if we look here, we see that phone looks like people look up customer records by phone number fairly often, but there's no index on that. So what that tells us is that it may be that an index on that column might be useful, and it might speed up your access by your users to that data. So we come over here to our SQL tab, and we execute a query looking up a customer record by phone number. What we see is it takes 1.2 seconds to return a single record. That may not be a big deal, but in this case our table has 100,000 records in it. But what if it had 1,000,000? Well, then you need to add a 0 to the end of that, and now suddenly we're looking at 12 seconds to look up a single customer record by phone number. Using a combination of that information that we've just learned here by executing that statement ourselves, and the information here on the Query Analysis tab, seeing that that query is run fairly often, we can make the determination that our system would benefit from adding an index to the phone number column in the customer table. We go a step further and make that even easier for you. All you have to do is right-click on that item, select Create Index. It asks you for a new index name, and that index is created for you right there. Once our index is created, we refresh it, we see that it now is indexed, and now let's run over and execute our query again. Wow, 78 milliseconds. The great thing with that is that you'll get that same response time whether the table has 100,000 records like it does here, or even if it had 1,000,000 records, you'd still get about 78 millisecond response time for the query. So as you can see, that powerful feature makes it very simple to go in and analyze the types of queries that are run on your data, and then make an informed decision on what indexes should be added to your system to give your users the best possible user experience with your application.
The next SQL query enhancement I'd like to look at is the ODBC JDBC prefetch algorithm. It's a mechanism used when retrieving SQL results. The driver can ask the server to return a block of resultant rows rather than a single request. This will deliver huge performance implications when used over high latency connections, satellite probably being the worst. But it's also noticeable when used locally. So let's have a look at a demonstration.
The BBJ, ODBC, and JDBC drivers have a feature built into them that we call prefetch. Basically what this is it's a mechanism used when retrieving SQL results where the driver asks the server to return a block of result rows as a single request instead of one at a time. Now while this is noticeable even when everything is run locally, all on the same machine, you'll find huge performance implications when using over a high latency connection such as a satellite or even just any internet connection. For example, if each request took 250 milliseconds to travel from the client to the server, it would take 25 seconds worth of latency time alone to make 100 requests to the server, where a prefetch setting of 100 would require only a single request and thus only take up 250 milliseconds of latency time. So let's take a look at this prefetch in action. What we have here is a select statement that we're going to run against a remote server. It's going to fetch 350 or so records, and it's going to run that 3 times. Let's run our test now. This first run of the test is using a prefetch setting of 10. And we notice here that it's taking approximately 2 seconds to fetch those 352 records, which gives us an average record per second fetch time of 174. Now let's see what happens if we increase that to 250 on our prefetch. And let's run that test again. We notice it's taking approximately a half a second to fetch the same amount of data that took 2 seconds before. Let's take a look at a result graph here to get a good visual picture of the difference. Notice here when our prefetch was at 10, the amount of time that it took. When our prefetch was at 254, there was a significant drop in the amount of time. And keep in mind, we were just dealing with 350 results. A lot of queries will return many, many more results than this, and so all you're going to see is an even bigger performance improvement the more data that you're fetching across that connection. One of the beautiful things with this feature is that it requires absolutely no changes in your code. It's completely transparent to your end users. All you need to do is make the setting in your ODBC data source configuration or in your JDBC connect string, and then you will benefit from this great feature.
Let's look at another database configuration feature, something called connection pooling, used by BBJ to allow JDBC ODBC connections to remain open and available for future use. It's completely transparent to the users, and the configuration is done from Enterprise Manager. It can be configured to communicate with any relational database management system with an available JDBC ODBC driver. There are a couple of options: global pools shared by all users and user pools specific to a particular user. So the use cases would be to limit the number of JDBC connections used at any one time by your application, and you get a performance improvement when your application makes numerous SQL open, SQL close calls in quick succession to that third-party database. It'll keep a specific number of connections always available for use. So let's have a look at that in action.
So let's take a quick look at the configuration of a connection pool. First, we'll give it a name. This is the name that will be used in our SQL open calls to access connections from this pool. We give it a JDBC driver class, a connect URL. In this particular case, we're connecting to our local Chili Company BBJ database. And then you can also specify the JDBC connection properties that are necessary to connect to the database in the way that you desire. There are other settings for connection pools as well, and information on those can be found in the basis documentation. So now let's take a look at connection pools in action. In our example here, we're going to run a query that opens and closes a connection 500 times. In our first example here, we're running that, and we're not using a connection pool, and we're just going to our local database. We see that it took 2.9 seconds to run 500 iterations. When we run this through a connection pool, you'll notice it took 247 milliseconds to run the same number of open and close operations, and that is because it does not need to establish the connection each time. It can reuse it from the pool. We see the same benefit when we go to a remote machine as well. In this example, we're going to connect over the internet without a connection pool. We're only going to run this 10 times because we're going over a much slower connection. Note it took 4.5 seconds to run 10 times, but with our connection pool, it took approximately a half a second to run 10 times. And so you can see the great benefit here of using connection pools within your applications.
So we've just looked at how the connection pool can improve performance on connecting to a third-party database. But what happens if we want to connect to that third-party database from Pro 5, which doesn't have an ODBC or JDBC driver, or from Visual Pro 5, which only has an ODBC driver? Well, we can take advantage of BBJ's functionality and the X-call. The X-call will give us access to the BBJ JDBC driver, and then we can access any third-party database as we would from BBJ, Oracle, MySQL, SQL Server, or any database with a JDBC or ODBC driver. Let's have a look at that in action.
Using xcall, we can access the BBJ JDBC driver and take advantage of the powerful new database engine found only in BBJ. We can then take advantage of such features as stored procedures, triggers, and the optimizations and performance improvements found in BBJ. The other benefit that this can give you is the ability to access third-party databases such as Oracle, MySQL, SQL Server, or any other database that has a JDBC driver available or an ODBC driver available. We'll take a look at these two examples right now. First, this example will connect to a BBJ database and return the data to our Visual Pro 5 application. Note here our JDBC connect string that will connect us to the BBJ database server. Let's execute this here. Type in our password, and we see that we get back the data found in that database, and it returns it to our Visual Pro 5 application. Now let's take a look at accessing a MySQL database from Visual Pro 5. Also note that this is possible to do from a Pro 5 application as well, where it's running on some flavor of Linux or Unix. We note our new connect string. This will connect us to a MySQL database. Let's run that now. And we see the results come back. So this powerful new feature gives you the ability to not only access your current data found in your data files for your application, but you can also get to third-party data without having to go outside of the Pro 5 and BBJ environment.
Thanks, Jeff. So what have we covered today? We've looked at how we could replicate our data and make it more readily available to third-party users, be they actual power users running some sort of reporting software, or be it a third-party application trying to access the same data. We can keep it live, real-time, and it won't affect our production system. We've shown you how we can improve the performance by adding the requisite keys, how we can analyze the tables to make sure that the SQL engine uses the appropriate data path to get to that data as fast as possible. We've looked at prefetch and connection pooling algorithms, and we've also seen how we can access third-party data from within our business basic applications, be it BBJ, be it Visual Pro 5, or even Pro 5. So let's have a look at some of the benefits of today's session. Peace of mind data backups, no user inconvenience. You can access third-party data from any basis app. We've improved query performance across the board. We've shown you how you can get real-time query access without impacting production data. And we've shown you how you can secure that data via more granular level permissions from any third-party or basis SQL engine. We've looked at how you can create cost savings. Currently, maybe you're replicating data to some third-party database and putting it in a separate data warehouse. This can reside on a separate system. It can utilize basis technology, giving you significant cost savings and reduced complexity. It gives you access to data real-time, not in a batch type download of the data to a third-party database. Your basis tools and techniques are available for database and file replication. The object level permissions give you that granular control, and you see the performance optimizations to make sure that never again are your users concerned about the performance of accessing that data. And you can access third-party data then even from Pro 5 and Visual Pro 5 applications via BBJ. So let's take your questions.